Hey folks, here's an early morning video for me. I just wanted to give you a video on how to do this so that you don't have to listen to me a million times. So when we're writing covalent formulas from the names, we've got a couple things we want to consider. These are usually the easiest ones to write. First off, when you're looking at the name, the prefix will tell you how many of something you have. So tri means 3, pent means 4. If you've got no prefix, it means there's just one. And with covalent compounds, if there's just one in the first atom, then we don't say mono. We just say whatever it is. And we can see that naming convention with CO, which is carbon monoxide. That's a gas that comes from incomplete combustion, and it kills a lot of people every year. And we also have carbon dioxide. So it's not monocarbon monoxide, and it's not monocarbon dioxide. It's just carbon dioxide. So trisulfur, we have, whoops, why did I do phosphorus? Trisulfur has 3, pentabromide. So it means we have 5 bromines. Boron heptafluoride, just like carbon monoxide, we have 1 boron. Hepta, we look up here and it means 7. So we have 7 fluorines. And then finally hexanitrogen, so 6 nitrogens. And trichloride, so that means we have 3 chlorines. You should be able to go from name to formula and formula to name. Let's look at the other one. So when you're naming these guys, it's a mixed practice. So there are covalent and ionic compounds in there. So when we're looking at magnesium fluoride, that's an ionic compound. So let's identify which are ionic and covalent first. Nitrogen and sulfur, that's covalent. Nickel and selenium, that's ionic. Phosphorus and chlorine, that's covalent. Silicon and chlorine, that is going to be covalent. Iron and that polyatomic ion, it's ionic. Cobalt 2 phosphide, that's ionic. Carbon monoxide, that's covalent. Sodium chlorate, that's ionic. And tritellurium octaboride, so tellurium and borine. Well, with the naming convention, we know that it's covalent. Now we need to write the names. The formulas. So for magnesium, I write down Mg, and I want its charge. It's going to end up being +2. And then I also want to write down fluorine with its charge, because we're going to crisscross those charges. What you're going to, let's write this down here, Mg +2 and F -1. When we crisscross those charges, we make them subscripts, and that's going to give us MgF2. So that's going to be the formula we write in there. So that's what we're going to do for these ionic ones. Now for the covalent ones, don't forget we use the prefixes, so it tells us how many. So pentanitrogen just means 5 nitrogens. You've got those prefixes on the back of your periodic table that I've shared with you multiple times. So nitrogen's got 5, and sulfur has 7 because of the naming. And don't forget, when we've got these transition elements for ionic compounds, that 2 there, or the Roman numeral, tells us what the charge is, because these things can have different charges. So let's take a look at that one. So we're going to say we have iron, and it's telling us it's +2. And now I need to look up the permanganate, and I don't want to mess this up, so I don't have my periodic table. So the permanganate is something like MnO2. Come on. Just don't want to mess up its charge. MnO4. Oh, come on. What is its charge? -1. That's what this is saying here. So then we crisscross those charges. It's going to end up being iron with permanganate and a 2 outside those brackets. So that's going to be your answer for this one. Hope this helped. Reach out during class if you guys need anything. And I'm going to figure out how to stop sharing my screen.